Hi, everybody. Welcome and thank you for joining us today for a live webinar, SecOps Automation in Openshift Clusters using Kyverno with the HCS and Nirmata teams. My name is Randy. I will be your moderator for today's session. I do have some housekeeping items I want to share with you all. This session is being recorded and will be sent out shortly after we conclude. And then we do want to make this as interactive as possible, so please feel free to put your questions in the chat and we will address them in the Q&A session at the end. I would like to go ahead and introduce our panelists and have them do a brief introduction for you all today. Yvonne, if you want to go ahead and kick us off.
Yes, thank you, Randy. Hello, everyone. Welcome to this webinar. My name is Ivan. I work as a DevOps engineer at HCS company in the Netherlands. It's a consultancy company specialized in Openshift, Red Hat portfolio, observability, and now also a little bit of Kyverno. So for the last 2 years, I've been working as a cloud engineer in an Openshift enablement team where we worked with Kyverno. And in this session, I will demonstrate some of the policies for you for examples, maybe to give you some ideas what you can do with it. So Anusha.
Thanks, Evan. Yeah, happy to have you here. So I'm Anusha. I'm a product manager at Nirmata. I've been at Nirmata for the past couple of years, and I've been working on Enterprise Kyverno and the Nirmata Policy Manager. I'm excited to be here today to specially talk about Kyverno's use cases in OpenShift environments. Welcome, and let's get started with our agenda. So this is going to be our agenda for the next 1 hour or so. So we'll start with a brief Kyverno overview because today we are going to be focusing on Kyverno and its usage in OpenShift environments. I want to level set the field on what Kyverno does and how it can be useful. Then we'll dive deep into the use cases in OpenShift clusters. So Ivan here will walk us through how he has utilized Kyverno in building OpenShift platforms, how different platform teams use Kyverno in automating their day-to-day operations. And then I'll talk about the supply chain security use cases that come in very handy in OpenShift environments. And we'll also talk about the Nirmata Policy Manager. I'll give a quick overview of what Nirmata can do. And we'll end with a quick Q&A as well. Okay, so let's get started. So this will be a short overview of Kyverno because I think most of us here know what Kyverno is, but just to again level set the field. So Kyverno is a CNCF policy engine, which is created and maintained by Nirmata. So it is currently in an incubating phase and it has applied for graduation as well. So it's the most loved policy engine out there. As you can see, some stats I've put here. It has about 5K plus GitHub stars. We have a thriving Slack community of over 3,000 members. And with over 3 billion image pools, Kyverno is being used for a wide variety of use cases in various organizations. So how does Kyverno work? So Kyverno utilizes the concept of dynamic admission controllers in Kubernetes. So in Kubernetes, there are 2 types of admission controller. One is mutating admission controller and the other is validating admission controller. So Kyverno makes use of both of them. So let's consider a typical API request lifecycle. So here, if you consider just the gray boxes over here, so whenever I do an operation, say something like kubectl get pods, the first part that always happens is authentication and authorization. So this is to ensure that me who has executed the command kubectl get pods is allowed to do so or not. Can I get pods in my cluster? So once that is verified, then comes the webhook part. So if a mutating admission webhook is registered, the request is routed through the admission webhooks. So as the name suggests, your incoming API request can be mutated. You can change that as well. So if I was creating a pod, if I was creating a deployment, the mutating admission controller can add specific labels to the deployment, or it can change the number of replicas. So it can mutate the request in any way possible. After mutation, we do some schema validation, and then there is validating admission webhook. So as the name suggests, this actually validates whether an incoming request should be allowed to etcd or not. So Kyverno again makes use of this capability, and you can write a bunch of policies and rules which evaluate to either true or false. If it evaluates to true, then the validating admission webhook allows your request to persist into etcd, and if it evaluates to false, your request will be dropped. So this is how Kyverno can keep misconfigured resources out of your Kubernetes cluster. Kyverno itself is Kubernetes native. By that, I mean Kyverno is made up of a bunch of custom resources and controllers. So all the yellow boxes here are custom resources. So things like policies, policy exceptions, policy reports. So all of this, just like you were doing kubectl get pods, now you can do kubectl get policies or kubectl get policy reports. So if you are aware of the Kubernetes ecosystem and how different tooling work together, you can easily start working with Kyverno. The learning curve is pretty low, and all your existing tooling will fit very well with Kyverno as well. These are some of the top use cases that we have seen work with different, after working with different customers, and not just Openshift. Kyverno works across any Kubernetes distribution. So these are some of our top use cases like pod security. You can have workload security best practices like, like you need to pull images only from certain registries. You need to make sure your images are signed, your images are verified, and so on. You can also use it for multi-tenancy best practices. And this is, I think, one of the most important topic for today, which we'll be talking about. Ivan will showcase us how he uses Kyverno to automate some of these operations, like whenever a namespace is created, how do you create network policies, resource quotas, and all of this to ensure your your multi-tenant environment is secure. Then also in terms of software supply chain security, this is something, again, I'll walk through today, and we can see how Kyverno can be used to verify container image signatures. So there are a lot of use cases of Kyverno. And like I mentioned before, Kyverno is being adopted by a wide range of users. And today we'll particularly talk about Kyverno's usage in OpenShift environments. And also another thing I forgot to mention in the beginning, if there are any questions, feel free to ask in chat. We'll be happy to answer, or you can also, we also have a Q&A section in the end, and we can chat then as well. All right, now moving on to use cases in OpenShift clusters. This is where I will hand over to Ivan, who will walk us through some of his experiences of using Kyverno in OpenShift environments. Over to you, Ivan.
Yes, thank you, Anusha. So we'll be talking about several Kyverno policies that we've created to make your life some easier, for as well as people who use the OpenShift platform to land their workloads, but also for the administrators who are taking care of the health of the cluster itself. So if you imagine something like this. So you're working in a company that has purchased OpenShift, and you have about 40 or 50 teams that are all working on that same cluster. OpenShift is not very cheap, so it makes sense to create one shared cluster for all the teams to work together. But now comes the difficult part. 50 teams trying to work there to land their workload on the cluster, but without proper tooling or solutions or ideas, things get quite messy. So you need some form of standardization, what people can do, or how developers should do it, and also take away some repetitive tasks for the administrator. So without Kyverno, we had a lot of administrative work, and also our teams needed to do a lot of things themselves, what basically every team did in the same way. So you have all teams doing the same thing over and over again. That's where we tried to use Kyverno for, and we succeeded in that as well. So next slide, please. In this demo, I will show you 5 examples of Kyverno policies that we've created to solve specific challenges. The first few are related to cluster resource quota. So make sure that not one team can claim the entire cluster, so another team cannot work anymore. So we need to distribute the available resources on the cluster to each team without interfering in each other. We also have automatically provisioning GitOps. That is one of the tools that every team in our company is using to provision their applications. So each team has its own GitOps instance, but try to avoid that every team has to create such an instance himself we created a Kyverno policy for this. And lastly, we've taken a look at a Kyverno policy that controls that teams cannot over claim resources on a storage layer. So we've seen it happen that one team by accident claimed too much storage, and then the whole cluster was in a standstill mode because the operators of Openshift itself also need storage, and yeah, things came to a halt. So that's where we put Kyverno into place to create a solution for that. So I'm going to share my screen to show you some of the policies and also demonstrate how it looks like. So let me share my screen quickly. Share my desktop. If all is well, you should be seeing my desktop with a terminal and my VS Code. Everything all right? I see a thumbs up, so yes. This must be looking great. So I have a small folder here in my VS Code. In advance, you don't have to make screenshots or type over the code that I show you after the demo. We will share them with a GitHub repository, so you can take a look at there and also get pieces of the code if you want it. So the first policy that I'm going to show you is create sandbox namespaces. I explained that you have a lot of teams working on the same cluster, but when a new team begins and they first opens the Openshift portal, they will see nothing. So it would be very nice that a team who logs on to Openshift for the first time, they already see a namespace that they can deploy their application in. So we automatically provision a sandbox namespace for each new team that onboards. And this is how it looks like. You have a cluster policy, that is the Kyverno policy that we created. And the most interesting part to show you is that a Kyverno policy has what it's called a match. That describes that something happens in the cluster. In this case, a cluster resource quota is being created. And you want to automatically do something else with this. So as soon as the cluster resource quota is created, what Kyverno does, it triggers a generate rule, that's how it's called, and it will create a namespace for you. I highlighted it here, so it will create a namespace with the same name of the cluster resource quota that I already created and add it with -sandbox. So this is what happens. The administrators creates a cluster resource quota, and Kyverno creates automatically a sandbox for this. So let's have a look at how it looks like. So I have prepared a small script that I will trigger. Let's take a look. If I say also get groups and also get cluster resource quotas. There is nothing on the cluster. It's empty. No team has onboarded yet. So what I'm going to do is I prepared a bunch of groups. Let's quickly show them on the screen. Copy. So I have a bunch of groups, just some random names I took somewhere. And for each group, I will create a cluster resource quota. First, I will create the group. So groups created. So in each group, there is one user developer who is member of each group. And only for the first 10 of those groups, I will also create a cluster resource quota. So these groups, they are assigned a specific amount of quota to work on. And what Kyverno does is, like I showed you in the policy, that it will automatically create several sandbox namespaces. As you can see, there are a couple of seconds ago. This is a live demo, so I hope everything will work fine for this session. So 10 sandbox namespaces for each of these teams are automatically created. Of course, this is a very simple task. It's a very simple policy. But this is the nicest policy that you can create to begin with if you are first using Kyverno. So next policy. Like I said, if you have 50 teams working on the same cluster, you want to have some kind of a quota distribution on all those teams to make sure that nobody can claim the whole cluster resources. So what we decided to use is, if I show you the resource quota of any of these teams, like the cluster resource quota. Let's say get cluster resource quota. Cool. Oh, sorry for the typos. I will show you what it looks like. And so it would be best to select all the namespaces that have a specific annotation with a key called quota, and the contents the same name of the group which it belongs to. So if you can, if you will see, you will take a look at the sandbox namespace of this team. So you get namespace cool-sandbox. You will see that it has an annotation with that same key quota with a value of cool. Now, how did we do this? Before we had Kyverno, teams had to create this annotation themselves. Maybe they forget it or they make a typo. So we created a Kyverno policy for this. This is the second policy I wanted to create. That's called label and annotate namespaces. So basically, the strategy is the same as the previous policy. Something happens in the cluster. In this case, something happens to a namespace. This is the match. Yeah, we coded some preconditions to filter out some default namespaces for the cluster itself. That's not very important for this demo. But what happens here is that instead of creating something else, the generate, if you remember, this is a mutate. So we adjust the properties of the namespace to add a label and an annotation. In this case, the quota. Where this label is used for, I will come to that in the fourth example. So in this case, Kyverno takes care of placing that quota on that namespace automatically. And if you can scroll, if you see in the cluster resource quota that it has in the status detected that cool-sandbox has such an annotation and has decided, well, part of this quota can be assigned to that namespace. So normally an administrator would have to set this annotation, or the team will have to set it. One of the teams forget it or mistypes. So Kyverno helps this, and this is a trusted solution for us. So the next step, and that has also something to do with the assigning the right quota to the right teams, is to make sure that no developer can create namespaces for other teams. So a developer should only be able to create namespaces for his own team, in this case, the development team. And I will show you the restrict namespace policy, and I will show you how it looks like. Again, something happens in the cluster. Someone or something creates a namespace and a project request. And what happens here, that's a cool feature of Kyverno. It will not create something, but it will validate something. So just to make sure that somebody is not doing what he should not be doing. And in this case, it will validate if the user is creating a namespace that is not beginning with any of the groups that he's member of. Sounds complicated, but it's very simple, actually. So I'm switching to my second tab. I'll say who am I? So I am user developer. Let's take a look at my namespaces. Oh, let's see. Local developer. Oh, let's see. What's it? Projects. So I have access to these 10 projects because I'm a member of the groups who have been granted access to these namespaces. So what happens here if I just checking my code? If I would say try to create a new project dev00-psql. Well, he cannot see any of the namespaces that begin with dev00. Actually, he's not even a member of a group called dev00. So the policy should be blocking this because the name of the namespace is not beginning with one of the team names. And indeed, this policy has blocked my request because the project I'm trying to create, dev00-psql, has found a restriction that saying that the only names approved for your namespaces are the ones starting with, and then all the groups that he is member of. So yes, if I try to create, in this case, dev01, then the policy allows the creation. So a user can only create a namespace that belongs to the group he is member of. The team looks best for, and the combination of this makes it so that distributed team member cannot by accidentally claim resources from another team, or maybe creating namespaces inside other teams to place the workload over there, so that any of the teams can only create namespace for themselves. I see my webcam has lost connection. Am I still? Can you still hear me?
Yeah, we can hear you. I think you were cutting up quite a bit.
Okay,
So
perfect.
yeah, Randy,
Perhaps
the camera.
without video, no worries. So, let me go to the fourth example. This is the GitOps example. We've decided in our company that all the teams should be using GitOps, also known as Argo CD, to help them deploy their applications. Well, Argo CD is not hard to install, but it's also not easy to install. So we created a policy with Kyverno that if you create a namespace that ends with GitOps, again, this is the match, the policy, what happens inside the cluster. Something happens to a namespace that ends with GitOps, and we just generate something else. In this case, we are automatically adding a role binding. So if a developer creates the namespace, this policy automatically creates the role binding that allows other team members from the same team to access this namespace so they can work together. And also what it does is, that's basically a second rule. Again, the namespace ending with GitOps is being touched, created, or whatever, then it will generate an Argo CD custom resource. That is the custom resource that GitOps that will be used by the operator to create a GitOps instance. So let's have a look at how it looks like. So who am I? So I'm still user developer, and let's create dev01 because I can only create it for dev1, and then end it with GitOps. So namespace is being created. Let's see if there are role bindings. Yes, let me know. Wide. You can see that inside this namespace there is a new. Oh, I think my screen is not wide enough to show the users. Oh, it does. So we have, where does it say? Right here. A role binding is created that grants admin rights to the group dev01. That's the same group that the namespace is beginning with. So immediately all your colleagues of the same group has access to this namespace. What also happens is because we create an Argo CD instance, and from there Kyverno is done, but the operator will pick it up and will start deploying an Argo CD instance. You can see it's been running for a couple of seconds now, and if all goes well, let me pull up my Argo CD. So now my Argo CD is deployed. And from that, it's no longer a Kyverno party, but an Argo CD party. So we can automatically provision Argo CD/GitOps to any team who just needs to create a namespace, and they can start from there. Okay, so yeah. And the last policy that I wanted to show you, one of the challenges that we had was object storage. Each team has permissions to create object bucket claims. That's what it's called, like on Openshift. And we found that if you are running in Openshift, you can create basically an unlimited amount of object buckets. These are not handled directly by the cluster resource quota, but what we have, what did we find is that when object buckets are being deployed too much, the cluster storage gets full, and then everything comes to a halt. So we needed something to block overcommitment. And how did we do this? Again, we used Kyverno to create policy for this. Something happens inside a cluster. Someone is trying to create an object bucket. And what happens? We gave it a mutation rule saying if the user tries to create an object bucket with unlimited size, that's one of the options that you have in Openshift. We say, well, we don't allow it, but we do allow it, but give it a default value. And that's done by the additional config. That's basically an object bucket property. But with the plus sign, you can add a maximum size only if this maximum size was not already there. So if you give it a size and try to create it, fine. But if you create an object bucket and not specifying the maximum size, then we will give it a maximum size of a very small value. If it's not big enough, then you should override it or give it a size from the beginning. So, but the interesting part is the next rule. As soon as you create an object bucket claim, you don't want users to create, let's say, 100 gigabytes of object bucket. So what we tried to do is use one of the features of Kyverno. Is very cool. The API call, then you can basically query any API endpoint as long as available to the cluster. But this is an internal API. So we try to, let me the word wrap. Yeah, so we queried the cluster resource quota endpoint, and we filtered out a specific value inside the cluster resource quota. Let me quickly pull up the example over here. So here you see that we specified in the quota, hey, you can only create maximum amount of 200 megabytes. So it will look up this value and compare it against the object buckets you're trying to create. If the value is bigger than this value, that's again a validation. So it will deny if the maximum size that you specified in your object bucket is greater than what is specified in your quota. So you cannot create an object bucket that's larger than 200 megabytes. So let's see this in action. We'll say project dev01 PSQL. We'll say add object bucket claims. So we don't have any object bucket claims yet. So let me give you the code that I'm trying to create. Kopiëren. Let's create small object bucket claim, OBC small. We give it an additional config like a maximum size of 100 megabytes. So this should work because it's smaller than what your quota decided. So I'll say apply minf. Let's try to create it. Object bucket created. Perfect. Okay, now let's try to create a large object bucket. So again, I have a specification that says, well, create one with 1 gigabyte. That's bigger than your quota. So you should not be able to create this one. Okay. Yes, it works. Kyverno blocked this request because, and then the custom error message that you can program yourself. You can basically put any information in there. So it says, well, your request for 1 gigabyte exceeds your quota. Very simple. Now, so the API call was one of the nicest things. So let's take one last object bucket to prove that the first rule of unlimited bucket claims also works in the Kyverno policy. So I'm trying to create an object bucket called OBC Unlimited. It has no maximum size specified. So let's try to create it. It worked. So I'm trying to create a bucket of unlimited size, and it worked. Why? Let's see, get object bucket claim, dev01. OBC unlimited. And there we go. The additional config, maximum size 100 megabyte was automatically added by Kyverno. You don't have to watch for object buckets with unlimited size anymore. You can better take control of the storage distribution in your cluster. And yeah, basically that's what helped in stabilizing your cluster. So this comes to an end for my demonstration. I hope you liked it. Anusha, back to you.
Yeah, thanks, Evan. That was amazing. So there are a couple of questions in chat. Maybe we can answer those before we move on. So the first one I see is, how can we patch the existing resources like deployment in all namespaces? So you showed about mutate, generate, and validate, right? So what if my deployment is already existing in a namespace and I want to, mutate or patch those? So how can you do that with Kyverno? Do you want to take that, Ivan, or I can take that as well?
Yeah, I can answer this. So Kyverno doesn't only look at, has the possibility to react on something that's happening, like a create or an update. But it has also parameters to look at existing objects. So there's a small flag for that in each policy that you can specify yourself if it should work on existing policies or not. So you can choose what happens. So yes, Kyverno can do this.
Yeah, I tried to look up the policy, an example for it. So just sharing here. So you can mutate existing resources as well. So this is the flag that Ivan was talking about. So if mutate existing is true, it means whatever policy that you write for your existing cluster resources, this is applied as well. Okay, I hope that answers your question, Kanika. The next question we have is any operational challenges with Kyverno components in the cluster, and as Kyverno best practices, do you recommend anything? When did you face any of these challenges or any challenges running Kyverno in Openshift clusters?
Then I have to look back to when I started with Kyverno. First, I had the privilege that one of my colleagues already had a couple of examples set up, but then we also take a look in Kyverno.io. It's a website with all information that you can find on Kyverno. There is really structured documents that you have a good bunch of information. So I think the learning curve was also not too big. And also good to mention is there is a great community on Slack. There is a big channel with lots of people who are also knowledgeable. If you put up a question, you get fast answers and ideas and examples. So yeah, I was quite happy with the time that we need to spend to get familiar with Kyverno. So yeah, I would recommend take a look at it. Maybe it can help you.
Yeah, and also to add to that, like from our other customers and users as well, what we have seen is in case of busy clusters where you have like lots of pods being recreated all the time, or deployments are created, deleted, and so on. In such clusters, HCD can be overwhelmed pretty quick because of the large volume of reports that are generating. So not just policy reports, Kyverno also generates these intermediate reports that it needs. So if your HCD is overwhelmed, then obviously your API server performance goes down and so on. So what we've done in Kyverno 1.12 is we have introduced a new component called report server. So with report server, what you can do is offload all of this HCD load into an external database. So you can have an external managed database like RDS that's running in your cloud. Or you can also configure it to offload to an external HCD instance so that your cluster HCD is pretty stable and that does not take a performance hit. So I can share this blog post as well towards the end, but this is available Kyverno 1.12 onwards. So we have done some testing, and what we've seen is it reduces your cluster HCD load by about 70%. So if you have a busy cluster or if you see a lot of reports that are being generated, so this definitely we would recommend to use report server. And of course, there are other Kyverno configuration related details. Depending on your environment, you might need HA, you might need to fine tune your CPU and memory usage and so on. So yeah, I think if there are like more questions related to Kyverno configuration and best practices, please reach out to us. We'd be happy to help. Yeah, so moving on, I see there are a couple of more questions, but I think we can cover that towards the end. I quickly want to talk about supply chain use cases. So Ivan mostly spoke about, he actually covered quite a lot of use cases in Kyverno. Kyverno majorly has 4 types of rules, which is validate, mutate, generate, and verify images. So Ivan showed us 3 of them. I'll be talking about verify images, which comes in handy for supply chain security use cases. So why, image security matters? Why should you care about signing container images and so on? So mostly it is useful in enterprise grade security and compliance use cases. So as we know, Openshift is often deployed in highly regulated industries like financial services, healthcare, and government entities where strict compliance controls are needed. So image signing ensures that only authorized and verified images are used. So it helps to meet several compliance mandates like HIPAA, PCI DSS, or any other compliance standards that you may have implemented in your organization. It's also useful in case of multi-tenant environments. So we saw Ivan showed us how a shared cluster needs to be secured. You need to have automation in place so that one team does not misuse another team's resource quota and so on. So this is a common practice in OpenShift environments, and not just OpenShift, in fact, in any other environment. I liked one point that Ivan mentioned that, OpenShift is expensive, so is every other cloud provider's service. So while some teams may prefer to do cluster as a service, it's also a common practice to have shared clusters. So in such cases, different teams and departments, they share the same infrastructure. So ensuring that only trusted and secured and signed images are deployed across different projects or different namespaces, it helps to maintain a secure multi-tenant environment. So one team cannot deploy applications in another team's namespace. Then it's also useful in integrating with OpenShift pipelines. So if you want to implement shift-left security strategy in your org, this is definitely a good use case for that. So OpenShift pipelines, which are built on Tekton, they allow you to integrate security early on in the development lifecycle. So what you can do is you can sign these images as part of your build pipeline and use Kyverno policies to enforce that these signatures are verified at the time of application deployment. You can also use this to control over external registries. So OpenShift image streams, they help you to control from which external registry or from which registry you can deploy your deployments from to your clusters. But what Kyverno can actually complement this workflow. So it can enforce that any image that you pull from external registries are actually signed and verified, so that it has not been tampered with from the time you push to a certain registry to the time you're deploying it to a cluster. So this adds that additional layer of security to your platform. And then lastly, it's about complementing OpenShift RBAC controls. So we all know that OpenShift has a very robust RBAC mechanism in place. So it can restrict who can deploy and manage workloads. But with Kyverno policies, you can ensure that even if a user, so if I am a user, I have access to or I have permission to deploy something into the cluster, I would not deploy something that is not signed and verified by my build system. So even if a user has rights to deploy something, they can only deploy it signed and verify images. Again, this adds that layered protection to your platforms. And also about namespace level policy enforcement. So I think we already touched upon this. So we have because in case of like shared environments, different teams will have different namespaces or different projects that they have access to. And for example, say there's an application related to payments which is exposed to the internet. Those kind of applications or namespaces will require the highest level of security as opposed to say an internal application which is not even exposed to the internet. So you may need varying level of securities. So Kyverno policies, you can enforce them on a per namespace basis. So for the payments app, you can say, I want only signed and verified images. Whereas for an internal app, you can relax this condition. So Kyverno allows you to do that as well. So these are some of the things like why you should sign container images and why only verified images should be deployed into production. And I want to quickly showcase a small demo regarding this. I'll quickly do that because we are already, I think, 45 minutes into this. Okay, so I have a cluster here that I've already created a while ago. I have some basic pod security policies running. Other than this, I don't have any image related policies. So I want to, first let's try to run some images. So I have a sample Python application. So all this is doing is, exposing port 80 and running the app. So I have pushed this to my Docker registry, and this is my app with 1.0 tag. So if I try to run this, oops, I had not cleared. I was just trying out before the demo. Okay. Okay, so while this is deleting, I might as well show what the policy looks like. So like Ivan mentioned before, we have pushed all this code into a GitHub repository. So it's public, so you can use it for your reference. So if I go to Kyverno demo and image verification, so I have this verify image YAML. So here you can see this is a cluster policy and the name of my policy is check image. The validation failure action is enforce. So this field particularly tells us if this is set to enforce and if the rule evaluates to false, then my pod or deployment will be blocked. If it is set to audit, then it means it will only give me auditing information, but my deployment won't be blocked. And here I'm matching on pod. So whenever a new pod is created, this particular policy and rule will be evaluated. So here I have my image reference is Docker Hub and my repository here is Anusha. So star indicates any image in this repository should undergo this policy check. Now, this is very powerful in Kyverno. You can write any complicated regex. So you can say dev dash star. It means all images starting with dev in this repository should undergo this very policy check. And it's checking with this public key. So for signing the image, I have locally created a public private key pair and I've signed my image with the private key. And this is the corresponding public key of it. Only those images which have been signed by my private key will be allowed into the cluster. So that's what the policy does. So what I wanted to show earlier is I don't have any verification image policy. And if I try to run this, obviously this will be created, which is good because I trust this particular image. But what happens if I run something like an unsigned image? So even that got created. So now this could be any malicious app, or even it could be a 2.0 version of this app, which is not being signed and with the same set of keys. It means my image has been tampered with and I should not be deploying those. So in this case, I actually don't want to run an unsigned image. So let me delete these quickly. And next we'll apply this particular policy and see what happens then. Yeah, so while this is deleting, I just want to, answer one of the questions, which is very much related to this. That's why I thought I could answer later. So can we use CI pipeline to validate policy like test suite before going to apply to the cluster? Definitely, yes. So you can use Kyverno CLI. There's a Kyverno CLI that you can use in CI pipelines. And Nirmata also has a CLI called NCTL. So using that, you can actually use NCTL in CI pipeline like GitHub Actions, or it could be GitLab pipelines. So you can verify all your manifests, your Kubernetes manifests that are there against the standard policies that you would anyway run in your cluster. So if you know that something is going to be blocked, you will get that feedback much early in the pipeline. So I think we have another webinar and even blog posts related to the same, which we'll definitely share. So yeah, similarly, even this particular policy, you could actually hook it up in the CI. You're anyway signing the container image, but you can also see at the time whether against the particular image verification policy, you can see whether it's going to be allowed or not. So let's apply the image verify policy. Okay, so, okay, my image verification policy is here. Now, if I run my Python application, it should run because this application was signed with the correct set of key pairs. And now if I run the unsigned application, it should be blocked. And we get the message saying this resource was blocked because of the following policies, no signature found, because this is some random image and this is not signed at all, which is good. But I also want to show you another use case where now this is the example of say two different teams. They are trying to deploy two different applications. Now this is a signed to image. So it's just a different image signed with a different set of keys. So if it's another team's image that somebody is trying to deploy in my namespace, obviously there's a mismatch with the keys, and Kyverno will block that as well. So earlier it told us no signatures found on the image. Now it's no matching signature because it is signed with a completely different set of keys. So Kyverno provides you those guardrails in terms of completely unsigned images signed with a different set of keys, so that only your trusted images make it to your clusters. And just for this demo, I've used cosign for signing my images. You can also use notation. You can also use keyless signing. A lot of these are already supported by Kyverno. Yes, now I want to actually go back to the slide. Yeah, we just have 10 minutes to go. Randy, do you want me to continue or do we look at the Q&A?
I think you can go for a couple more minutes and then we'll go into
Okay.
Yeah.
Okay, great. So let me then talk about Nirmata. How can Nirmata help? So we saw a lot of use cases about how Kyverno can be used in your OpenShift environments. We saw about validate, mutate, generate, and image verification use cases. So how can Nirmata help? So all the use cases that we saw today was for the central box in Kubernetes clusters. Nirmata is cloud provider and Kubernetes distribution agnostic. So all the use cases we saw today is easily, applicable to any other Kubernetes distribution. And like I said, we have a CLI called NCTL. You can integrate NCTL in your CI pipelines to get that early feedback for your developers. We also extend the same concept to cloud services. So for example, if you're running your workload on ECS, Fargate, or even just virtual machines, we can scan for all the misconfigurations that are there and provide the same set of feedback that we give for Kubernetes clusters. And Nirmata itself provides the central platform where you can, and in a single place, you can manage all of your pipelines, clusters, and cloud services. And we have different workflows defined around it. There are workflows around policy exceptions, or if you want remediations. So we saw a lot of these issues occur because our resources are misconfigured. So we give you recommendations on what the right set of configurations should be, and it becomes easy for your developers to fix those issues pretty quick. We also integrate with several DevOps tooling, like suppose say there's a misconfiguration or somebody tried to deploy an unsigned image, we can send out an alert to Slack, to PagerDuty, or whatever tooling of your choice. Nirmata also integrates with other cloud native projects, like Ivan was mentioning about Argo CD. So Nirmata very efficiently integrates all of our workflows with GitOps tooling like Argo CD and Flux. If you're using tools like Crossplane to provision your resources, or even Terraform, so Nirmata integrates with those as well. So yeah, I think with that, I just want to highlight that with Nirmata and using Kyverno, our goal is to prevent misconfigurations, whether these misconfigurations are in pipeline, clusters, or cloud. It doesn't matter, any misconfiguration that's out there, we want to prevent those. Yeah, and I just had, I can just show the dashboard for a bit. So yeah, so this is the Nirmata Policy Manager dashboard. So this gives me a quick overview of what all clusters are present, how many repositories, it can be your GitHub, GitLab repositories, how many policies are present, how many remediations are available across all these repositories. All these reports I can view on a per cluster basis, namespace, or repository basis. So I can scan all types of files, not just Kubernetes manifests. I can also scan Terraform files or Docker files. And it gives me a complete view of what are all the findings that are there, what are all the resources that are impacted. For example, this is a demo resource that's there, and it says remediation available. So this particular app has 2 violations and I have 1 remediation available. So this tells me this particular configuration is missing from my demo deployment. So all I need to do to fix this particular misconfiguration is to add this in my deployment spec. So this, Kubernetes is not really easy to deal with. Like all these configurations take time to debug and actually fix those. So with help of these remediations, you can quickly find a fix for your issues in production. And then we have different clusters that you can onboard and all the events and activity you can monitor. So for example, I had onboarded my cluster to this particular dashboard, and we can see that, resource blocked. So this is the thing that we just tried a couple of minutes ago. It tried to block my signed pod. And you can see if something is being modified or created or blocked, all of the notifications and audit trailing you can find all in one place. Yeah, so I think with that, I want to just conclude. Yeah, so how can we help? We, at Nirmata, we are the Kyverno experts. So we can help you fully leverage Kyverno's capabilities. If you have any questions on fine-tuning Kyverno or adapting all the different use cases that you saw today in your own environments, please reach out to us and we will love to help you. Ivan, do you want to add anything to it?
No, that's perfect how you described it. So for customers in the Netherlands who are also seeking help for Openshift or Kyverno related issues or challenges, then you can reach to HCS Company. So we have a HCS Company website that you can access.
Yeah.
Awesome. Do we want to hop into Q&A and get to at least 2 of the 3 questions really quick, if that's okay with everyone?
Yeah, definitely.
Okay, it looks like Sathi has a question. Can we validate manifest files used for creating any apps in Argo CD with Kyverno? And examples, we do not want developer to create, apply, manifest a resource of a kind of app project or change any permissions under app project. I think that might be for you, Anusha.
Yeah, I'm just trying to read and comprehend the question. So it's about validating manifest files. So I'm assuming you want to validate custom resources such as an app project. So I think that is very much possible because the Kyverno resources, even if you look at any sample policy, under the match block, you have this, match what kind you want, whether you want to match on deployment or pod or resource quota or anything. So in your use case, it would be match on app project. And you can obviously write the rule as per whatever, your use case where you say, you don't want certain users to not perform certain actions. So that is, yes, very much possible. We actually have a working example of this with when we did integration with Crossplane, because Crossplane also has set of custom resources and we can write Kyverno policies for the same. I hope I interpreted that correctly. So if there's anything else, please, reach out to us and we can discuss more. And I think Sati had another related question. Details on documentation. Yes, I'll share that in chat.
Great.
Yeah, I also see a question by Peter coming up. He asked, have you been able to handle all onboarding for new users and projects with Kyverno policies from a single trigger resource that you initiate, like a resource quota? Well, actually, how we did this is we saved all the cluster resource quotas for all the teams that we have onboarded in Git. In this case, Git could be GitHub or Bitbucket or GitLab or wherever. And then we actually created a single Argo CD instance for the administrators. And that constantly looks at the repository where the cluster resource quotas are saved and makes sure that, so Argo CD makes sure all the cluster resource quotas are created and Kyverno picks up the rest of the activities. To give you an idea how big our company has created this in this particular customer, we had about 60 teams, so 60 cluster resource quotas, and each quota generates not only the sandbox but 3 other namespaces as well. So each cluster resource quota creates 4 namespaces. So in total, 240 namespaces with all kinds of additional network policies inside each namespace and permissions and so on and so on. And literally that takes about 30 to 40 seconds because we test this every month, that we destroy the entire Openshift cluster. So every team should be able to reproduce their application from code. But everything before that, onboarding teams, creating cluster resource quota, and everything that Kyverno does after that will take only about 30, 40 seconds for the whole company. So yeah, we did it. And it works like clockwork every time. So, yeah.
Awesome. Thanks, Yvonne. I know we have a couple more questions. We can take those offline. So Ramesh and Anil, I know if you have some questions, I'll reach out to you separately. That way we can get those answered. But it looks like we are at time. So I do want to go ahead and thank you all for joining today's session. We really appreciate you taking the time out of your day. A special thanks also goes out to our wonderful panelists, Anusha and Yvonne. Thank you so much for all of your wonderful insight and knowledge. Once again, this session will be sent out shortly after, so be on the lookout for that. And then we hope you have a great rest of your day. So thanks, everyone. I appreciate it.
Thanks, everyone.
Thanks, everyone. Bye-bye.
Bye.